So here till now we have covered the topics what is science and what is physics. Now we are moving to the next topic, that is fundamental forces in nature. So let's see what is about the fundamental forces in nature. So we have divided physics into two main domains, that is macroscopic world and microscopic world. Means macroscopic world where all the things we are dealing are at macroscopic or large scale, while microscopic world means where we are dealing with the things or phenomena at minute scales. Okay, so fundamental forces are present in both the domains. Let's see what are these fundamental forces. If we talk about the macroscopic domain or macroscopic world, there exist two fundamental forces that actually work in this area. So these two fundamental forces that work on macroscopic objects are gravitational force, and the other one is electromagnetic force. Okay, so these two forces act in the macroscopic world. Now if we talk about the microscopic world, means we are now talking about minute scale. So microscopic world may the two fundamental forces that act in microscopic world are strong nuclear force and weak nuclear force. So what we get is the fundamental forces. Now these are the four fundamental forces, two for macroscopic world while two for microscopic world. For macroscopic these are gravitational force and electromagnetic force. For microscopic these are strong nuclear force and weak nuclear force. Let's talk about all these forces one by one. So gravitational force is the force of mutual attraction between two bodies because of their masses. Okay, what is gravitational force? It is the force of attraction or I should say mutual attraction, as both the bodies attract each other. It is the force of mutual attraction between two bodies because of their mass. Okay, so this is the gravitational force. Now electromagnetic force is the force acting between two electric charges. Okay, electromagnetic force acting between two electric charges. Now if this charge is at rest, if the charges are at rest, then electrostatic force acts between them. And if the charge is in motion or present in a magnetic field, then a magnetic force act on these charges. So basically electromagnetic force is the combination of two possible cases, or we can say that electrostatic forces and magnetic forces are inseparable and both are considered as the two faces of a general force called electromagnetic force, or I should write it as electromagnetic force has two possible faces, right? First is electrostatic force and other one is magnetic force. Now, this electrostatic force is about the charges at rest. When the charges are at rest, then they either attract each other or repel each other. This force is called Coulomb's force or electrostatic force, right? And if we talk about magnetic force, so here magnetic force is about the moving charge in a magnetic field. And these two combinedly forms electromagnetic forces. So electrostatic forces and electromagnetic forces acting on the charges are actually the two phases of electromagnetic forces. So these are the two forces that are present at macroscopic level. If we talk about microscopic level, so there are two kind of forces, that is strong nuclear force and weak nuclear force. Let's first talk about the strong nuclear force. It is the force which binds together the protons and neutrons in a nucleus is called strong nuclear force. So basically the nuclear force that is acting between protons and neutrons inside the nucleus. As we know that nucleus consists of nucleons, that is protons and neutrons, and there is an attractive force acting between them which keep them binded. So this force, this binding force that keep them bind together is called a strong nuclear force. Since the force is very strong, attractive in nature, so it is called a strong nuclear force. So basically strong nuclear force is the force that binds together neutrons and protons inside the nucleus. So that force is called strong nuclear force, and this is actually a very strong attractive force. Okay, now come to the weak nuclear force. What is the weak nuclear force? So the difference is that this weak nuclear force is the force that appear only between elementary particles that involved in nuclear process, such as the beta decay of a nucleus. Okay, like weak nuclear force is the force that appear only in a nuclear process. Let us write it here. Weak nuclear force is the fourth fundamental force, and it is the force that appear only between elementary particles. Okay, only between elementary particles involved in a nuclear process. For example, beta decay of a nucleus. So this force is called weak nuclear force. This was all about the four forces. We can note here on the basis of the strength of these forces is that, suppose I have considered gravitational force has strength 1, then the electromagnetic force, the second force, that is the electromagnetic force, I can write it as 10 to the power 36 times stronger than the gravitational force. So electromagnetic force is 10 to the power 36 times stronger than the gravitational force, while the strong nuclear force, the third force, that is the strong nuclear force, is actually 10 to the power 38 times stronger than the gravitational force. And the last one, that is the weak nuclear force, is 10 to the power 25 times stronger than the gravitational force. So this is the relative strength of these forces, that gravitational force को अगर हम 1 consider करते हैं, then electromagnetic force is 10 to the power 36 times of the gravitational force. Strong nuclear force is 10 to the power 38 times of the gravitational force, while the weak nuclear force is 10 to the power 25 times of the gravitational force. Okay, so this is the comparison of their strength. One more thing is there, that gravitational force acts on all the particles. This gravitational force acts between all the particles. Electromagnetic force acts between charged particles. strong nuclear force acts on nucleons while weak nuclear force act on elementary particles. Okay, so this is for all the particles, this is for charged particles. Strong nuclear force is for nucleons, that is neutrons and protons, while weak nuclear force is for elementary particles only. So this was about the fundamental forces. Okay, so coming to the next topic, that is about the conservation laws. So let's talk about conservation laws. As we are studying the physical phenomena happening around us, so in any physical process involving different forces, some other physical quantities, or like energy, momentum, etc., etc., so some of these physical quantities remain unchanged with time during the phenomena, then such quantities are called conserved quantities. So the physical quantities that remains unchanged with time during a process are called conserved quantities, and the laws which govern these conservation or the conservation of these quantities are called conservation laws. So conservation laws basically are the laws that govern the conservation of physical quantities with time during the process. Okay, so in classical physics, or we should say at macroscopic level, we generally deal with the four conservation laws. These conservation laws are about conservation of law of conservation of energy. Okay, second is law of conservation of linear momentum. Next, law of conservation of angular momentum. And the last one is law of conservation of charge. Okay, so these are the four conservation laws that we usually deal with macroscopic phenomena. Now let's start with the first one, law of conservation of energy. So this law states that energy can neither be created nor be destroyed, but it can be changed from one form to another. Okay, law of conservation of energy. First I am talking about the energy conservation. Okay, so this law states that energy can neither be created nor be destroyed. That means in a process, the total energy of an isolated system remains constant. It cannot be created nor be destroyed, but it can be converted from one form to another. This is also going to add here, but it can be converted from one form to another. Okay, so what is law of conservation of energy? For an isolated system, the total energy remains constant, or we can say it as energy can neither be created nor be destroyed, but it can be converted from one form to another. This is the law of conservation of energy. Second law is about the linear momentum. The law of conservation of linear momentum states that if there is no external force acting on a system, then the linear momentum remains constant. Means we have a system where we are studying a process, but there is no external force acting on a system. So the law states that if no external force acts on a system, then its linear momentum remains constant. All right, so this is the law of conservation of linear momentum. Now similar is the law of conservation of angular momentum. In third case, we are talking about angular momentum. So this law states that if no external torque acting on the system, then its angular momentum remains constant. Means for a linear momentum we need no external force condition, while for angular momentum we need no external torque condition, as there is a rotation. While we are talking about angular, so there must be a rotation. So the statement will be, if no external torque acts on a system, then its angular momentum remains constant. This is about the law of conservation of angular momentum. Now the last one is the law of conservation of charge. So this law states that total charge of an isolated system remains constant. It's similar to that of energy almost. So the fourth one is the law of conservation of charge. For charge, the statement is the total charge of an isolated system, the total charge of an isolated system remains constant. This is about the law of conservation of charge. Okay, so law of conservation of energy is, for an isolated system total energy remains constant, or energy can neither be created nor be destroyed, but it can be converted from one form to another. Law of conservation of linear momentum states that if no external force act on a system, then its linear momentum remains constant. Similar in case of angular momentum, if no external torque acts on the system, then its angular momentum remains constant. And in case of charge, it is, if the total charge of an isolated system remains constant. Means if the system is isolated, then the total charge within the system will be conserved or remains constant. These are the laws of conservation that usually act for macroscopic systems. Okay, so in this chapter we have covered what is science, what is physics. We studied about both the things, that what is science, what is physics, and after that we have studied about the fundamental forces acting in nature, and further we move to the conservation laws. So this was all about the chapter number first, that is the physical world, from class 11th. Okay, so I hope you all get the concept of physics or the idea about what we are going to study from chapter number 2, or what we are dealing with in physics. So I'll come soon with the next video that consists of chapter number 2, and till then you stay tuned and keep studying. Thank you.